Hi, I'm Luis Barbosa, Solution Architect Manager here at Blue Orange Digital. And today we're going to talk about the newest breed of data integration platforms. So in the recent past, we've been talking about modern data stack, and with the support and the leverage of AI, some of these platforms evolving into intelligent integrated data platforms. Databricks definitely one of those cases. Let me share my screen. So we're going to see here a simple example how Databricks evolved in one of those newest platforms of intelligent integrated data platforms. Databricks originally was conceived as a private implementation of open source service like Hadoop, AGFS, Spark, and so on. And currently, it became a powerful platform in which it's possible to ingest data in different formats like structured data, semi-structured data, unstructured data, even real-time streaming data. And it creates or work on the paradigms of a lake house, a data lake, so the underlying files can be consumed and ingest directly. And on top of it, it's created an abstraction layer that for the end user, it's behaved or perceived as a full warehouse system and query system as a very usual, very used to work with regular database. So this is done through their data lake. They offer a proprietary format called data lake, even supporting multiple types of formats, either for transactional operational data or analytical data. So formats like Parquet, ORC, and some others, it's fully supported, but it offers the data format as their standard one. And then all of these, it's managed and provided on the unit catalog that serve as a governance layer. And then from there, it's possible to do multiple ingestions from multiple origins, multiple types of process, and serving the data in multiple ways, either for traditional warehousing or traditional data analytics, but also to AI and machine learning scenarios, and not only that, even for generative AI. So currently, it's possible to support full LLMs directly into Databricks. Actually, Databricks released their own LLM model called DBRX, which is going to be the topic of our next article, next video, right? Anyhow, you're going to see here a very simple example, but interesting to see how the paradigm work in general. So we have gonna have a very simple CSV input file that's gonna ingest it into a staging table that's gonna serve as our data entry table, do a very simple transformation and make this transformer data available in an analytical table in a different format as gonna see. And from there, it'll be possible to serve to multiple purpose. On a simple example here, we're gonna serve it on as visualization feature, doing classical or classical even basic data analysis. But anyhow, it's interesting to see how it's possible to do so even within the Databricks environment. It offers not only data visualization, data analytics, but up to dashboarding features, right? So let's see it in practice. All that gonna use here is totally feasible to use and to try under the free version, the community edition. Here I have a full-blown implementation or installation of Databricks, but again, it's totally possible to work on the community version, right? So simple items around here. The community going to see that is less options, but anyhow, the core ones have things like the workspace in which you have the notebooks. Notebooks is the standard way to interact with data, write your code, either in different program languages like Python, R, Scala, and some others, and also SQL-based interactions, right? Also, it's possible to manage clusters, CPU, GPUs, and all the computing power that's available under the warehouse service or lakehouse service. It's fully managed through here. And I was just saying, the whole data management is done through the catalog feature. So throughout the catalog, you have the abstraction of a regular database or warehouse structure with databases, schemas, and tables and other object elements underlying it. But behind the scene, what we have is a full HBS system, right? It's even possible to browse through that. So there is a button here. On the community edition, normally you have to, it's a little different interface. The button is around here, and most of the cases is not a standard configuration. You have to go on your administration menu and enable the DBFS visualization. Anyhow, my point being here is, let's say that I want to upload a file as baseline of this new table set. Oh, here it is. Let me upload our CSV file, and as I try to upload the file, it's gonna suggest me to configure it as underlying virtual table, right? An abstraction of the table. I can do this throughout the user interface, but probably at this point, I want to focus our work directly on the notebooks, so it's more reproducible and manageable within a centralized piece, using code as a main resource rather than user interface, right? So let's create a notebook to start working with. So here on the notebook, there is an AI assistant. I'm not going to use that for now. As I said, within the notebook, there is support for multiple languages, mainly Python, Scala, and R, and also SQL, Python being the standard one. So let's start with something as simple as showing what kind of database you have for now on this environment. Oh yeah, and for this notebook, I have to start a computing service, right? So let's start that and attach to the notebook. And from there, we can start interacting with our environment, right? So you can start with SQL commands to show what kind of database you have for now. So let's change it for SQL. It's gonna do like a magic link here, magic code that's gonna enable our SQL command. Our first SQL command is gonna be to show the existing tables. So it's starting our cluster. All right, starting. As it starts, I guess I can get started with the serverless service, which is also quite interesting. We have this serverless SQL service. So we have a computing power, especially for SQL queries, that's available without the effort of managing physical resources, right? But anyhow, let's run it under it for now. Once you have to do Python code, have to change to a proper computing service. But yeah, here we have it, the existing databases. Let's create a new one. And then I'm creating this database called LLB. And now if I rerun this one, we have a new database, right? And then we can start using it. LB. Sorry for the typo. All right, we are using, and then let's reference our file, right? So a CSV file, it's something simple enough. It works as operational data, could be different sources, could be blob storage from many cloud vendors, could be operational tables from different SQL servers, SQL providers. Anyhow, even as something as simple as CSV works as operational data, as a table that's going to serve as a staging area for us. So it can be the entry point for the data for the lakehouse, right? So what we're gonna do is to create a virtual reference for it. I'm gonna call it staging. All right. So I'm gonna create like a virtual table, a staging table. This staging name, I guess it's something more usual for the ones that work with Snowflake. It's also another platform from this new breed of data integrated services. We're gonna definitely have some material on them also. But anyhow, I can create the whole table without even mentioning the schema itself. The schema can be inferred from the data. And this virtual table, let's call it, is going to be pointing to the original file under the file service, file system that you just shown, right? So let's run this. All right, the table is created. And from that, we can either work with SQL queries as I've been doing so far. So we can do something like select from this newly created table, right? It's a table with cloud vendors and some of their servers and when the data to each service were released. And you could interact with also that data with Python code or in programming language code that's available here. So for that, let's switch to our proper computing service. And the interaction for it, the main APIs that you use to interact with it is Spark. Spark is very important, interesting that it enables parallel processing. So it uses parallel processing and leverage the main power of working of this kind of platform, right? Just make sure that I rerun this again so it understands the context that we're under the LB database, so I don't have to be always qualify the names of the tables of any objects that I refers to. Anyhow, within the Spark API, you can throw a command, something like this table function here that refers to the table, either physical table or virtual table as it is, and I can show the underlying data, right? It would work with this regular Spark syntax. It also would work with Spark running SQL queries besides direct SQL queries as we did here, right? So something like a Spark SQL function method here, and then we can have the SQL query within Python code. Here it is. It's another option. And then what you want to do is to create, then if this is our staging table, we have to create our analytical table. And for the analytical table, we should have the proper data format that are more performatic for columnar read in an analytical service, right? Here it's going to be quite helpful again for operational data, the transactional data, and serving as a ingestion entry point for the lakehouse, for the data warehouse. But once you read and transform the data, the final storage should be a storage mechanism that is optimized for analytical features, right? So let's create our destination table. in our destination table, we're gonna use the delta format that it offers. We could use something like Parquet or C, but delta probably is the native one to be used with Databricks. And for this, of course, I have to define the structure of the table, which pretty much similar to the original one. We are just add a new field of the number of days that each feature was released. That's going to be the transformation that's going to be calculated here. So the number of days that this service was released. So let's run this as SQL command. I'm going to create this cloud service analytical table. And from there, we could do the transformation with something like this. Again, we could keep using SQL. We could simply insert into the analytical table as a select from the staging table. And within my select, I'm doing a date diff to calculate the number of days that I would be interested, right? So that's a way to do it. Another way to do it using Python code could be something like this. I could do something like this. So using the PySpark library, for the PySpark library, I would reference the staging table and manipulate as it were like a regular pandas data frame, but it's not really easy, right? As you see, it's a different syntax. I can get the idea of a data frame, but the syntax a little different, right? It's much based on method and so on. Anyhow, the important piece here, as you're working with Spark, not Pandas directly, you leverage the whole parallel processing support that Spark offers, right? So I'm creating a new calculated column, and then finally, from that data frame that I created a new column, calculated in a new field, I can then save it as the analytical table, under the delta format management file, right? So that's pretty much it. I could run as it is. I guess it's work. Days release date, days. Oh, I have a little issue on the types using integer and long types. Maybe, yeah, I should change that for integer, but I can do in a second moment. Anyhow, what I show next is that yet another option would be something like this. So PySpark is quite interesting, not that hard to learn how to work with, but anyhow, a lot of people it's very familiar with regular pandas, right? So what Databricks did was to create an API. So originally they call it koalas instead of pandas. I sometimes even rename it as KS, as koalas, or PS, some people do, doesn't really matter. But anyhow, we can work with Spark as it were regular pandas, right? So as you see, you have the operation as like read CSV or read table, and from the table you can create a new column with the differences here as it were regular pandas, and then save it into a destination table or the analytical table as expected. But it's exactly the same operation that we did up above using directly Spark, but now with the pandas syntax. Keep in mind that's only the syntax. If you're doing this with regular pandas, we wouldn't leverage the parallelism process capabilities. But as it is, you can leverage the pandas syntax, but of course the underlying code is running actually is actually running Spark, right? And also have the data available on the analytical tables, we can start doing some analysis, right? Some visualization, and for visualization, we can use regular visualization libraries like Matplotlib, Seaborn, Plotly, and many others. We could do something as simple as aggregate data. I could throw a select using the Pandas API. And as I have multiple vendors, I could count how many servers each vendor has, right? That's exactly what I'm doing here. I'm grouping by vendor and counting the services, and then I'm bringing this aggregation. Oh, I forgot to run the import here. Let me run the import. And then from it, yeah, here it is. I have all the aggregation of different vendors. You see how Google has main service, Microsoft, AWS. From this sample file, it's not comprehensive, but I know anyhow it's interesting enough. And from these, probably a very good visualization element here would be a pie chart, the proportion of each vendor service. So I'm going to simply throw a command like plot and mention a pie chart, and you can see, of course, Microsoft Azure, AWS, and Google, the main service providers. And again, you can play around as much as you wanna. It's a simple, very simple data set. The last thing that I want to show is that it's also possible not only do some of these data analysis use cases, it's possible to even create full dashboards. So from here, you can create a new dashboards and reorganize all your information. Can throw away the visual elements that you don't need, and stick only with the ones that you would be interested. Right? Yeah, let's say that I'm only wanna keep mainly the graphs and probably the summarization. Maybe you can organize as you prefer. Yeah, it is. So something like this: have the summarized table plus the graph. Will create my dashboard and then publish the dashboard for whoever set of users wanna work with that. Right? Again, simple data set here, just to give an idea of the features. Right, so that's pretty much it. I guess the main point is how to showcases how the traditional modern data stack platforms become and evolve in a full-blown environment with not only leverage multiple data types and data services, but also enhance their computing power mechanisms and support up to the point that support AI scenarios and even generative AI scenarios, in some cases, hosting full-blown LLMs. And that's going to be the topic of our next conversation. So thank you so much. See you next time.